Hi, I'm Randall Heyman, a mathematics academic. For those that don't know, this is one of my Corona help playlists where I do quick turnaround videos to help educators and students. If after watching you'd like me to make a video for you or your students, you can drop me an email or you can comment below any of my videos. Okay, so we're heading towards this compactness, very important concept in analysis. So we're heading towards this. And we need to discuss open covers and finite subcovers. Before that, I just want to talk just about bounded. We talked about bounded sequences previously, but I just wanted to say, let's just imagine we're in a R2, for example. And we've got this set here. So a set S. What does it mean to be bounded? Well, it just means that we can put a ball, here's the origin, we can put a ball, so this is, let's call this point R. So if there exists an R, actually it'd be better to use the little r like I normally do. So this is a ball, so if you like, this distance out here is R. So if there exists a ball centered on the origin, can actually be centered on anything, but it doesn't really matter. Let's just say the origin of radius R, then we say that that S is bounded. Okay, now we wanted to talk about open covers and finite subcovers, so let's do that. Okay, so we're going to start with what we just have. So say we have a set S that's it's a subset of R, say Rn. So we can be multi-dimensional here. So we could have what we call a collection. It's a better word than set in this case. A collection of let's be P for open. I don't want to use O. P alpha. So this is sets. Oh, I'll explain it in a sec. So this is an open cover if each Pi is open, or an open set, I suppose. Let's do it properly. Is an open set, and S is a subset of the union of all these P. Let's call it P alphas. Actually, that can be an alpha back there as well. Doesn't really matter. And under here, it's sort of understood all alpha. Or you could say, because this would normally be, P1, P2, P3. So you might have alpha is greater than or equal to 1. So the thing that you should sort of maybe have in your mind here is that you could have this is S, and we have these set of P1, P2, P3, P4, however you want to have it, but ultimately at some point they all get, so I'll put this one here, P6. And so S is now contained in the union of all these open sets. So you might actually want to draw the sets like this if you were doing it properly, because they're open sets. Okay, so that's what an open cover is. This takes a while to get used to, this idea of open covers and finite subcovers. So let's talk about that. A finite subcover is finitely many of the those open sets, which still covers S. What does that mean? I.e., S is a subset of the union of the P alphas, where alpha is from some set A, and A is a finite set. So we saw that in example. We saw that above. I actually created back here. I created an open cover, but that was also a finite subcover, because finitely many of what I drew still covers S. So actually, if you wanted to, you could think about it like this. I could have made this one over here P7, P8, P9. Sorry, they should all be dotted because they're all open sets. So this would be, we could have then P10, P11, dot, 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 P over here we have P a million, and it just keeps going. There's an infinite number of them. In this case, that would be an open cover, because certainly S is here. S is certainly a subset of the union of all of them, but in this case, we could say that there was a finite subcover. So now S in this case would be a subset of the alphas in A of P alpha, where A in this case is equal to 1, 2, 3, all the way up to 6. So that's a finite subcover. Okay, that's all I wanted to say about that. In our next video, if you're interested, we will come up to the definition of compactness and see what that involves. If you've got any questions about any of this stuff with covers, please drop me an email or comment below any of my videos, and I'll try and help you out. And the same applies to anything in mathematics. I'm happy to help, be it at primary level, secondary level, or tertiary level.